Let us analyze this statement carefully. After that, we will then answer the questions when we have seen what we are given and what we are not given. The statement says a man faces difficulty while swimming in a dam. During the rescue operation, an inflated tube attached to a helicopter by a rope is dropped from the helicopter. The man, of mass 70 kg, holds onto the inflated tube of mass 40 kg. While the helicopter is flying horizontally at a constant speed, an average frictional force of 300 newtons is exerted on the main-tube combination while they are dragged horizontally along the surface of the water by the helicopter. The rope makes an angle of 50 degrees with the surface of the water, as shown in the diagram below. Assume that the rope is inextensible and massless, and the water of the dam does not flow. Here we are given the masses. The mass of the man, which can be presented by mm, and the mass of the tube, which can be presented by mt. They then tell us that the helicopter is flying horizontally at a constant velocity. Now, when they tell us that the velocity is constant, we remember that acceleration is change of velocity with respect to time. So if the velocity is constant, it's not changing, then that makes our acceleration equal to 0. They then give us a friction force and lastly an angle. The fact that our motion here is horizontally means that we will be dealing with some of the forces along the x-axis. So their first question requires us to state Newton's first law of motion in words, draw a free body diagram, calculate the tension in the rope, and then at 2.4, they are asking us how will the tension of the rope change if the helicopter accelerates while dragging the man. They also tell us that the friction force and the angle between the rope and the surface of the water remains the same. Choose from increase, decrease, or no change. Then they want us to give a reason on our answer. On 2.5, they are telling us of another situation again. How does this situation differ from the previous one? So on 2.5, they are telling us about a different situation. So what I will do is I will first calculate the first situation, and then we will come back and analyze the situation on 2.5, and then we will do the calculations after. Let us do the problem solving part. So they said we must define or explain Newton's first law of motion. What Newton's first law of motion speaks about is an object or a body that is at rest. It then speaks of an object or a body not at rest but moving. So we said we don't use moving, we use acceleration on the second or on our second law when we explained it. On this one, we don't use moving, we use motion. So the second object on Newton's first law is in motion, but at a constant velocity. So always remember that the first law talks about two things: a body or an object at rest, and a body or an object in motion, but this motion is at a constant speed. So what it basically says is that when a body or an object is at rest or is in motion at a constant speed, it will remain at rest. If it's at rest, it will remain in motion at a constant beat, at a constant velocity if it's in motion at a constant speed. Unless this situation will change only, so they will have change only when a resultant force or a net force or unbalanced force acts on the body. So if there is no resultant force, net force, or unbalanced force acting on this body or on this object while it's at rest, it will remain at rest. But once there is a force on it, it will not be at rest. Its state of rest will change. Even this one, if it's in motion at a constant velocity, it will continue that way unless a resultant force or a net force or an unbalanced force is applied or acts on it. So that is Newton's first law of motion. On our second question, as always, they asked us to draw a free body diagram for this scenario. So our free body diagram here would be like this. We have a man and a tube. So we would present a man and a tube with a block. If you want to, you say empty, man and the tube. What do we know on this scenario? We have our normal force and we have our gravitational force. Why this one is longer? It's because we know that when this guy is swimming, the force of gravity is dragging him down. That is why he must be rescued. The gravitational force is dragging him down deep to the ocean if he is in the deep to the dam. They said he is in the dam. So the gravitational force is the thing that is making this guy battle and require rescue. So the gravitational force is bigger than the normal force on this scenario because this man is not standing on the ground. The gravitational force wants him on the ground. Too bad for him, he is in a dam. So the gravitational force I'm sorry about laughing. So the gravitational force wants him under the water. And now he is gonna die. So let's continue. On this case, the helicopter is pulling this guy on this direction, right? So the friction force must be pulling this guy on this direction. So on our free body diagram, we will also present our frictional force as Fr We then have that force of a rope, which we might call it a tension force. Then that's the force, bigger than any of the forces we have drawn, longer than any of the forces we have drawn. The reason it's because this helicopter is dragging this guy to this side. So this force must be bigger for this guy to be dragged on the left out of the dam. Someone might not draw this free body diagram like this. Instead of drawing that one, another student will remember that here we have fx or tx. Since this arrow point to that direction, then this one will point to this direction. And we also have ty or fy. So some students might come here and draw that fy, ty, and also draw tx or fx. So if you draw it like this, then there's no need for this one. Now on our third question, they said we must calculate tension of the rope. So when we are given an angle, we remember that through our trig ratios, tx, we will use cos x since we'll be using the adjacent and the opposite. So we remember that t is hypotenuse, sorry, not opposite. T is hypotenuse. You remember Pythagoras theorem. And fx or tx is adjacent. So cos theta is equal to adjacent over hypotenuse. So our adjacent is here, is fx or tx. Let's use tx. And our hypotenuse is t on this case. So this is the same as saying t when we cross multiply, t cos theta is equal to tx. We know that theta is 50 degrees. So this is what we want. Where does this help us? It helps us because since we have seen that our motion is horizontally, then that means we are dealing with some of the forces along our x-axis, which is equal to ma. And if we consider our forces along the x-axis, we've got this tx, which is going to the negative direction, and we've got our friction force, which is going to the positive direction. So now what we would do is, like, physics doesn't force us to consider the direction like I've considered them as if we are doing math. In physics, you can take this direction as positive and take that one as negative, as long as you don't take this one as positive and take that one as positive. So now let's come to our sum of the forces here. This would be equal to, we said Tx is equal to this, Tx plus our friction force equal to Ma. Remember that we were told that V is constant. And when V is constant, we know that the acceleration is equal to 0. So this means that here we will substitute 0. Whatever we have on M will be gone, will be equal to 0. So T will change and become negative, and T would be substituted by T cos theta plus Fr equal to 0. Our theta, we know that our theta is, what is our theta? Theta is 50 degrees. So we would have minus T cos 50 equal to, we will transpose, the friction force will come to this side and become negative. We were told that our friction force is equal to 300 newtons. So this would be minus 300 newtons. We will have to divide by cos 50, cos 50. Now let's divide by negative cos 50 and negative cos 50. This one will cancel this one, and the sign will cancel that sign, cancel, then our answer will be positive. Then T would be equal to, what is 300 divided by cos 50? Our calculator say it's 466,71. Seven newtons. That is our answer. What was gonna happen if some student said cos 50 is equal to, then they said 0.64, then they say 300 divided by 0.64. Then the student, you see, was gonna get 468.75. So this happens when you round off before arriving to the final answer. I think that answer would be accepted. Now we are done calculating the tension force. Now they asked us what will happen if the helicopter accelerates. So now when the helicopter accelerates, this makes our velocity not constant. So they wanted us to tell them what was going to happen to T, the tension. So if this accelerates, the higher the velocity, the more the tension here. So they said we should say increase, decrease, stay the same. So T will increase. Then they said to state the reason. It can be many reasons that you can state. There can be many reasons that you can state. When A increases, you remember, we know that acceleration is directly proportional to force. So when A increases, T will increase. Someone might say what can be other reason? This Tx, someone will say Tx would be greater than the friction force. That is why T would increase. So These reasons, they just digging for your understanding. So you just put whatever reason that makes us see that you know your side, you know your story. So we will now analyze 2.5 and do the problem solving for 2.5. Now let's continue to 2.5. On 2.5, we are told that in another rescue operation, the inflated tube of mass 4 kg is dropped from the stationary helicopter and it strikes the water at a speed of 16 meters per second. The tube sinks vertically downwards into the water to a depth of 0.8 meters and then rises to the surface. This scenario starts by giving us the mass of the tube. Unlike the other one, we are not told the mass of the men that they want to rescue. Immediately after that, they tell us that the helicopter is in stationary, meaning the helicopter velocity is 0. And then they tell us the velocity of the tube, because they said the tube strikes the water at a speed of, so that's the velocity of the tube, and it's said to be 16 meters per second. Take this like this. If I throw a ball to you, like let's use a speed on this example. The speed of the ball that I'm throwing is 16 meters per second. So when you catch the ball, what is the final speed of the ball when it's in your hands? The final speed of the ball is 0. Why am I making this example? This example is almost the same with the tube that they are throwing to the water. Once the tube reaches the surface of the water or reaches the water, the tube's final velocity is 0. While they were throwing it, it was 16. Then that means that this 16 is the initial velocity. The final velocity of the tube is 0 until the man gets to a tube. Then the helicopter moves. Then that would be another case, and it would almost be the one that we have done before this one. They then tell us a change in height. The reason why we consider this as the change in height, it's because we are not told how high is our helicopter. The only thing that we are told is that the tube sinked and then rised back. So you know a tube, it sinked because of the speed, then went back to float. So when the man gets when the man gets into it, the man will float and the man will not sink. 2.5 now requires us to calculate the magnitude of the average upward force exerted on the inflated tube while it is sinking. We are told to assume that the average upward force is constant for the motion. What does that supposed to mean? This simply means that our acceleration due to gravity is equal to 9.8 meters per second squared. It's taken from our table of physical constants. Now that we have collected every information that the statement has given us, we are now ready to do the calculation. Let us do the problem solving. Here we are asked to calculate the upward force, and that is F up. From our statement on this scenario, We've seen that we're dealing with some of the forces on the y-axis, and this is equal to ma. Why? Because our motion is vertically, not horizontally. So where is this F up? We are told that this is thrown downwards to our water. This is our water. This is the dam. So our initial velocity, we've seen that is 16 meters per second. And our final velocity, our VF, is 0. Remember that example. When I throw something to you and you catch it, its final velocity becomes 0 when it's in your hands. So when this tube is floating here, its final velocity is 0. It will only change when that helicopter is no longer stationary, is moving to this direction or this direction. So VF is 0. Another thing that we are told here is the change in displacement. It's said to be 0.8 meters. I just want you to consider something here. When we throw this rope, which direction are we heading? The positive or the negative on our x-axis? Well, we are approaching the negative if we're going down, but physics does allow you to take this direction as positive. So if you do that, remember that any force then that would be upward, if you take this as positive, you will take it as negative. In order for you to understand what I'm saying, when I'm solving this problem, I will solve this problem on this side. On this side, we will take the downward direction as positive and take the upward direction as negative. So on this one, I will take the downward direction as negative and take the upward direction as positive. So you will see we will get the same answers, but we must be very careful. So let's start here where we take the downward direction as positive and the upward direction as negative. So on our formula, if we expand some of the forces along the y-axis equaling to ma, would remember that we've got two forces here. When this tube sinks, it will go back because of the air on the tube. A tube will not sink permanently because it's a tube. It must go up and float above the water surface, but it will first sink. So we've got this sinking force, which is presented by Fg. The reason why we have this sinking force, we know that it's because of the gravitational force. And according to our statement, we have seen that for us to get this force, we must take G to our table of physical constants. So G there is equal to 9.8 meters per second squared. So now the sum of the forces become Fg plus F up equal to Ma. So here we must remember that we said the upward force or anything that is going up, we will take it as negative. So this makes F up minus negative. So this makes Fg positive because Fg is an upward force equal to Ma. Now we have a problem here. We can get this one through mg. We know m is 4 kg and we know g is 9.8 meters per second squared. We know this m is 4 kg, but we don't have this one. We don't know this one, the acceleration. But because we have the final velocity, the initial velocity, the change in displacement, we can then calculate the acceleration through that formula which says v final squared is equal to v initial squared plus 2a multiplied by change in displacement. Notice that here we said we will take the upwards force as positive and the downward force as positive and the upward force as negative. This is drawn down. So if we are taking our change in displacement in consideration, our change in displacement mathematically is negative because if we were on our x-axis, for example, when you throw something, let's say there, okay, let's do this. This is 1, 2, 3, 4, 5, 6. How do you calculate a change in displacement? A change in displacement is calculated by y2 minus y1. So our helicopter, if it's there, y1 is equal to our initial. We were initially, because initially it's where we started, y1 would be 6. And if this tube, we say it here, then y2 would be 3. So what would be 3 minus 6? This would be minus 3. So our change in displacement when something is thrown from the bottom, from the top to the bottom, will always be negative. There is no way it will be positive. But because we said we are taking anything that is going downward positive, that means here we will substitute 0.8 as positive. Make sure you understand this because this is where the catch is. If you don't understand it, try your best to understand it, please. You will see we will do the different thing on this side. So what will be VF? It will be 0 squared, and this would be minus 16 squared plus 2 times A times 0.8. And this would be taken to this side. What is 16 squared? When you square a negative number, you get a positive number. This comes to this side and becomes minus 256 equals to 2. Oh, sorry. What is 2 times 0.8? It's equal to 1.6 A. So we divide both sides by 1.6 and our acceleration becomes 256 divided by 1.6. Remember that this is minus, so when you divide both sides by a positive, you will get minus 160 meters per second squared. So this tells us our acceleration is downwards. That sign tells us the direction of our acceleration. So now we can take this acceleration and substitute it to this formula, and after substituting there, when this is known, it will be easy for us to get F up. So let's do that. Remember that our acceleration was negative when we taken the downward direction as positive. So we will put it as negative. So here when you write it as positive, you should say downwards. Then so that we remember. Okay, we said we are substituting on that formula, right? Fg is mg. This becomes, let's use a different color now. This becomes 4 times 9,8 minus F up, which is what we want, and 4 times minus 160. So what is happening here is this will come to this side and becomes positive. So and become negative. 4 times 9,8 is equal to 33,2. So we will be left with F up, that is negative. This one also would be negative. So this one comes to this side and becomes negative 39,2. And what is 160 times 4? 160 times 4 is 640. Because of that sign, this one is negative. So what is the sum of this? This becomes minus 679,2. F up, remember F up is negative. So we multiply by negatives, by minus negative, by minus, by 1, sorry, by negative 1. I don't know what got into me. Then F up will be positive 679,2 newtons. So let us do this same calculation, taking now the downward force as negative and the upward force as positive. So we will just take answers from here. We will not punch them in a calculator. So on this scenario, when we're calculating v squared, vf squared, vi squared plus 2a, change in displacement, we said here any upward force will be taken as negative and any downward force will be taken as negative. So we dropped our tube, so our change in displacement is negative. So here we will substitute negative 0,8 because this tube is thrown down, and we said anything that goes downwards we will take it as negative. So here you substitute 0 squared and 16 squared, and you remember that here this initial velocity is going down. You must put negative. Oh, I'm sorry, here we were not supposed to put it as negative. We're supposed to make it positive, but that changes anything because we were squaring that. Here it must be negative. It can be negative here and be positive on that, and be negative on this side. Plus 2a, which is what we want, minus 0,8. So when you get 256 is positive, then this 256 will come to this side, and this would be negative 2a, okay, negative 20,8a. This is equal to 1,6. So you divide both sides by 1,6. 1,6. This 1,6 must be negative to cancel that. This one cancels these. And this negative here cancel that negative. So A here becomes positive. So don't make that mistake of saying that this A should be negative. This A should be positive on this case because we've taken the downward direction as negative. So when we substitute this A here, we will substitute this A here as positive. We won't do what we did here. We substituted A here as negative because our A was negative. So this just means that our acceleration is upwards when it's positive. Now let us calculate F up. So F up, we've seen that is sum of Fg plus F up equals to MA. What is happening to Fg? Fg is downwards. So now Fg is gonna be negative. F up, sorry, not Fy, is upwards. So F up would be positive. And M is positive and A is positive. So what is happening here? This will come to this side and become positive. So we'll substitute here and say 4 times 160 plus mg, 4 times 9,8. Then we would get positive 679,2 newtons. So we're still getting the same answer. Even if we flip the directions. But where is the catch here? It's here when you're calculating acceleration. When you take the downward force as positive, you must remember that your change in displacement, though it's negative, it's gonna be positive. When you take the upward force as negative, you are doing the good thing according to my preferred method. This one, it's gonna be negative, a change in displacement. When you get an acceleration, when you go and substitute it, keep the original sign. Thank you for watching.